Hola clase. In this video we are continuing with visualizing a system of equations in 3D, trying to imagine how it looks like, and now we want to see what are we searching for when we solve. So again, we're going to draw on what we know, how is a system of equations looks in 2D, to understand how a 3D one looks. So first of all, remember, what am I searching for when I try to solve a system of equations or simultaneous equations? I'm trying to find the solution where both equations in a flat surface are true at the same time. That is a point. And for me to get two coordinates, two values, I need two variables in two different equations. And that's why I call it a 2 by 2. That's what we did in year 11, year 12, and now. So now, again, remember I'm adding one dimension, I'm adding depth. So now, to get to a point, now I need three coordinates, because now a point in the space is not just an x and y, like here, is an x and y, and how deep? X, y, z. So I need three variables, and for that I'm going to need three equations to solve it. So now the system is going to look something like that. Still linear, okay, the degree of everything is still 1, and I only have coefficients, numbers, and a constant. How do I solve this? Now, I will still have elimination and substitution, they're just going to be a bit longer. So what am I going to search? If that point that I was searching there was where two lines crossed, where both equations were true at the same time, now what I'm searching is where three equations in a 3D are true at the same time. So think of that. If I know if this one represents a plane, any plane, okay, and this one represents another plane, it's going to have a different tilt. And again, you're going to have to be a bit imaginative here. When we are in class, we can play with this in GeoGebra or anything. But these two things are going to cross, and they're going to form a line. If I add an extra one, these three things are going to cross only in one point. And you actually have seen one of these probably for years of your life without realizing, because most of us live in cubic rooms and have corners. What's a corner? I've got one of the walls, I've got the other of the walls. Those are two planes and mostly vertical, or they should, okay, but those planes keep on going, yeah? The mathematical plane, not the wall. And what do I have on top of it? I've got an extra plane making the ceiling. Where do they meet? They meet in one point and only one point. This is the point that I'm searching when I solve those. So before, I knew I was finished when I had an x coordinate and a y coordinate. Now, I know I will be finished when I have an x coordinate, a y coordinate, and a z coordinate. If I know what I'm searching for, I will know when I'm done. If I have no idea what I'm searching for, even if I don't have to draw it, I will not know if I'm finished, if I'm answering what they ask me. So what I need you to take from this video and from the previous one, now in a 3D space, a linear equation is a 2D form, it's a plane. If I cut three of them, I need to cut three of them to get to one point only. If a point, now it's in a 3D, has three dimensions, three coordinates. So for me to solve three coordinates, I need three variables, three equations. And because I've got 3 and 3, I call it a 3 by 3 system or a 3D system. I'm done when I find the point, which means three solutions, or three variables, each one with their solution, to give one and only one point of all the infinite points of the space. That's what we're going to do, and that is what pretty much we're going to do for the entire unit. Solve these kind of systems. How? We're going to see it, and that's another video. Thanks for watching.